Okay, FRQ 8, two 15-minute FRQs here, and then there'll be another video for the 25-minute. First up, we have from 2019 a calculator one. This is one that falls in those accumulation problems, and so falls under the same rationale I've articulated several times as to why I still assign them, despite acknowledging that these problems, as they are, would not be on this year's AP test, because you won't have any problems that require you to use a calculator, as all of these accumulation problems back through 2010 do. Right, so as I've mentioned several times, I considered cutting them, but thought, it gives us a chance to review some vocabulary that could show up in obviously not in this form. You will not have a problem exactly like this one. This one requires a calculator. Look at the functions you're required to use, right? So while this specific problem in this specific form won't be there, and even some of the elements that are contained within this problem might not be, there are vocabulary, or I should say there are concepts that are contained within this problem that are good to review, even if they will take a slightly different looking form, ones that align more with some of the other FRQs we've done. It also gives us a chance to very specifically review how to use our calculator in different ways, so you have that as a resource on your AP test this year, because again, you can use your calculator, so you want to be practicing that, so you've got that to use. So I like these problems for that reason, as well as just giving us a chance to practice some of our testing strategies of some of the ideas we want to use on the harder parts that we will see on our AP test next week. Okay? So with all that being said, here we go, 2019. We have fish enter a lake at a rate modeled by the function E. Fish leave the lake at a rate modeled by the function L. Both E of t and L of t are measured in fish per hour, and t is measured in hours since midnight, t equals 0. So as I've said at different points in the last several videos, actually starting originally with the first tabular data notes video we did before spring break even, I myself always like modeling in like a little picture form the rates that we are given, especially because a lot of times if you do see those comparative rates, is what I called it back in the tabular data video, if you do see those comparative rates, a lot of times you will at some point be asked for what happens in a particular location. And so let me model that again one more time here. E of t is the derivative, or the rate entering the lake. This, by the way, is my lake. It's very pretty. And L of t is the derivative, or rate leaving the lake. And so inside the lake is E of t minus L of t. And then I've mentioned several times that I always like also saying like how many is in the location. So there was like an escalator problem, I think was part of FRQ 7. I don't know, there's been several that we've done, so I always do the total in the lake. Now this particular problem didn't give me that starting amount, so I'm going to call my starting amount, we'll call it F naught for fish starting amount. So my F naught, however much started in the lake, some amount, so total integral entered the lake, and some amount left the lake. So that's how many fish are in the lake, right? Okay, so part A, how many fish, so what's the total that enter the lake over the 5-hour period from 0 to 5, okay? So what's the total that enter the lake? Enter is E of t, and then this would be an element that you would not see for a number of different reasons, but being able to integrate, being able to take an integral could be on your AP test, and like I said, this gives us a chance to very specifically practice with our calculator one more time, because you can use it on next week's AP test. And so go ahead and take a moment, if you haven't already, plug that into your calculator just so you remember how to do it. If you do get stuck, send me an email. I can make a video, or you can take a picture of your calculator and I can help you, especially 83s with all your commas and parentheses and that kind of thing. I can help check that for you. But you should get 153.4576 or 45769, somewhere in that realm. They did say, though, to give your answer to the nearest whole number. And so this would be 153 fish. Okay? This one, this particular year, was worth 2 points. 1 point was for the integral, 1 was for the answer. Okay? B, what is the average number of fish that leave the lake per hour over the 5-hour period? The element of average that has been cut from this year's AEP test is specifically average value, but other applications of average could show up. For example, average rate of change could be there, right? So average as a whole has not been cut from the AP test. We do need to make sure we remember how to do average. Right, so again, just clarifying that to the best of my ability. And again, if there are questions, let me know. There are other ways I can say it, and so I just need to know if there's anything that you're still kind of getting hung up on. Okay, average is 1 over b minus a, 0 and 5, times the integral from a to b. Average what? Average number of fish that leave the lake. So what's that? Well, leaving the lake is L of t. So again, this particular one, this particular problem would not be on this year's AP test, but you could be asked to find like average rate of change of something. You could be asked to integrate, so it's good to practice using your calculator. So go ahead and take your calculator, plug that into your calculator, see what you get. Just to practice doing that one more time. And you should get about 6.059. And whether you round or truncate on this one, this does need to be 6.059, not 6. They didn't say to the nearest whole number on that one, so make sure you're accurate to 3 decimal places. Okay, 2 points, 1 for the integral piece, 1 for the answer. Okay, part C says, at time t for 0 to 8 is the greatest number of fish in the lake. At what time t, sorry, is the greatest number of fish in the lake? So we're looking for a maximum here. Maximum in the lake. Justify your answer. So this is my last chance to say this for this particular year. If you want my strategy, which again, make your own. You do not have to abide by mine. But my strategy, when I see maximums and minimums, I do the first 2 steps of maximums and minimums, and then I move on, and I do the rest of that part of the problem after I've done everything else I can related to my test. So the first 2 steps for maximums and minimums are taking a derivative and setting it equal to 0, and then finding those values that make your derivative equal 0. And I do those 2, especially the first one, taking the derivative and setting it equal to 0. Because a lot of times that one step will be its own point, so you don't want to lose out on that point. But if it's relatively quick for me to also find the places where my derivative equals 0, I usually will do that as well, because sometimes that's its own point. The rest of the work, though, like I said, I usually skip because it's 1 or 2, depends on the year, 1 or 2 points. It takes usually quite a bit of time for just 1 or 2 points. Now it's the same steps every time, so maybe you don't want to skip it. Maybe you're sitting there going, you know what, I like that it's the same thing every time, and so it's worth it to me to take that time because I know how to do the problem. Well, then great, don't skip it. Do the entire maximum or minimum problem all in one fell swoop if that's how you think it would best serve you, right? You need to strategize how you're going to spend your time, because you will have 15 or 25, depending on what problem you're on, 15 or 25 minutes to do the problem, and then 5 minutes to upload. And at the end of that 5 minutes of upload, if you have not gotten your work uploaded and you have not hit submit, like you're done, right? So you need to strategize time. You need to be watching that timer, getting your work uploaded, and hitting submit after you've uploaded everything, but hitting submit before that 5 minutes is up. Okay, so make sure you're thinking about strategy. Okay, I'm going to do this whole one though. I'm just sharing my strategy one more time. At what time t between 0 and 8 are we at a maximum in the lake? So derivative, what's the derivative of in the lake? Well, E of t, remember, is the derivative entering the lake. L of t, remember, is the derivative leaving the lake. So the derivative in the lake is E of t minus L of t. And we're setting that equal to 0. And if you had that written on your paper, you got a point. Which is why I said I always take that step, taking a derivative, setting it equal to 0, always. And then I usually will do the next step as well, which is finding the t's. Obviously on this test, again, one more time, you won't have to use a calculator, so you're going to be looking to factor or to somehow solve for t. You'll have your calculator there to help though, and so it's good to remind ourselves, how do we find zeros again? So we would plug in our e of t minus L of t, we'd graph it between 0 and 8, so that's what I made my window, 0 to 8. Physics students, make sure again that you're in radians, since there's a sign here, a trigonometric function, make sure you're in radians. Graphing it, there's your 0, you do second calc, or F5, or whatever the case may be. Calc your 0, and you should get 6.2035644. Oops, 6.2035644. Some years that will be its own point. Unfortunately, this particular year you did not get a point for finding your t. But I still do it because you don't know. You don't know what the rubric is. So I would find those zeros, and then here's where you decide whether to move on or not. Okay, so then we take our possibles, our zeros here, as well as our two endpoints, 0 and 8, and we plug them into our original function to see who's biggest or who's smallest. And my original function for in the lake is this guy up here. Okay, so since I'm now going to use F naught in my work, I'm going to define that for my grader. F naught is the number of fish in the lake at t equals 0. Okay? So plugging them in, fish in lake at t equals 0 is F naught. Fish in lake at t equals 8 is F naught plus the integral from 0 to 8 of e of t dt minus the integral from 0 to 8 of L of t dt, okay, which is F naught, and then you can take a moment, plug that into your calculator, the 0 to 8 e of t minus the 0 to 8 of L of t. Sorry, 1 second, my laptop just died, which unfortunately has my rubric on it, so you would like to fast forward the video. I'm going to take a bit here and plug my laptop in because I do need to see my rubric. Make sure I tell you where the points are located accurately. Okay, while my computer's turning on again, your 0 to 8 of e of t dt minus 0 to 8 of L of t dt, you should get 80.919977 about. And then the fish in lake at t equals 6.2035644, you would do all of the same thing. Your F naught plus the integral from 0 to, I don't want to keep writing that number over and over again. So I'm going to call this, what letter have I not used yet? I have not used D. So this is now D. So I don't have to keep writing that whole long number over and over. Although make sure that D doesn't start to look like a 0. I just realized that is the danger of D as your variable. So maybe use, Q or actually that looks a lot like 0 too now that I think about it. Maybe capital P, because we haven't used P yet anywhere. Something like that, if you don't have to keep using this letter over and over and over again. And then you would take that and you would plug it into your calculator. Doing your integral 0 to the 6.2035644. Calculator's back up. Or sorry, my laptop's back up, and you should get F naught plus 135.01492. And so which one of these is the maximum? Well, the maximum would be at t equals 6.2035644. You have two additional points besides the initial one that we said, that's setting the derivative equal to 0. You have 1 point that comes from your answer and 1 point that comes from your justification, which is all that work. Okay? Oh, we know this is the largest, by the way, because this was F naught. This is F naught plus 80. So whatever F naught is, it's 80 more. And this is F naught plus 135. So whatever F naught is, 135 is bigger. So that's why this is the maximum. T equals 0 would be the location of the absolute minimum. Okay? Okay, last but not least, we have D. Is the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m.? T equals 5. Explain your reasoning. Okay, I wanted to make sure that this one, that we walked through this one. It's why, like I said, I decided to keep assigning the accumulation ones because this part D is a prime example of being very careful about reading. Okay, and I know that sounds funny, but bear with me here. A common mistake that occurred last year for, as you look at kind of student work, a common mistake was on part D here, missing what is increasing or decreasing. There were a lot of students who were like, oh, I know increasing. Increasing is a positive derivative. I know decreasing. Decreasing is a negative derivative. And then they said, well, E and L are derivatives already, aren't they? Well, yes, you're right. E and L are derivatives. They're rates. And so if I can figure out whether, using E and L, if I'm positive or negative at t equals 5, won't I know if my thing's increasing or decreasing? Well, you would know something is increasing or decreasing. E and L, what are E and L measuring? Okay, together they're measuring the fish in the lake, right? E is the fish entering, L is the fish exiting. And so if we did E of 5, which is the T element in part D there, if we did E of 5 minus L of 5, what you'd be finding is whether the fish in the lake are increasing or decreasing, whether the number of fish in the lake are increasing or decreasing, because that's what E and L are. Okay, but unfortunately, they aren't asking me if the number of fish in the lake are increasing or decreasing. What are they asking me is increasing or decreasing? They're asking me, is the rate of change in the number of fish in the lake? Not is the number of fish in the lake increasing or decreasing. That's E of t minus L of t. That's the fish in the lake. But is the rate of change of the number of fish in the lake increasing or decreasing? They're wanting to know if the derivative of the fish in the lake is increasing or decreasing, meaning we need to take the derivative of the derivative, right? We need to know if the derivative's derivative is positive. Is the derivative's derivative negative? We don't want to use E of 5 minus L of 5. We want to use E prime of 5 minus L prime of 5. And that's a tricky idea. It is, and there are other ways to explain that. So if you have a question there or whatever, like, again, reach out. Let me know. I'm here to support you. Okay? So I would highly recommend using your calculator on this one. It's like I said, the other reason I wanted to walk through this. A reminder that if you do have it graphed, you can do second calc or F5. Derivative is down here, and you can do the derivative of E minus L, which is what I have plugged into my calculator, and I'll get negative 10.72278. Okay, or maybe you understood this idea, but you're not getting that in your calculator. Like I said, let me know. I'm here to support you in whatever your hiccup is. Okay, and so is this increasing or decreasing? Now, this would be decreasing because my E prime of 5 minus L prime of 5 is negative. This one is 2 points. 1 for considering E prime and L prime. 1 point for your answer with explanation. As always, with all of your problems as you continue through this video and what we've done so far, there's room for partial credit potentially. If you have a question there, send it my way. If you have a calculator question, send it my way. If you explained it differently and are wanting to make sure your explanation works, send it my way. Like, let me know. I am here to answer your question. Okay? Okay, second one from 2018, FF prime, F double prime graph section here. This was the second set of notes we looked at. We have the graph of the continuous function g. The derivative of the function f is shown above. Function g is a piecewise linear for -5 to 3. So I've got a bunch of shapes here from -5 to 3. And then I've got a function defined for 3 to 6. Okay? And then we have A, B, C, and D here. I like this problem for one very particular reason. Well, there's lots of things I like about it. But one of the reasons I wanted to make sure that this was on your last FRQ you did for homework is because of the 4 parts. In my experience going through this with students and looking at student work from that year, for a lot of people, part A was the hardest part of the problem. Again, not for everyone, and so you might be looking at part A going, I don't know why that's hard. And so great, if you're in that boat, congratulations, but it's still good to think about this idea, which is that sometimes the first part of the problem is the weirdest part for you, and you can't let that throw you. Skip it, move on, go to part B, do that, move to part C, skip around. It's okay to skip around. Don't leave it blank. Don't leave any part blank. Put something down, define stuff, take an integral, take a derivative, plug something in. If you're like, I don't know, but I've got an equation, I can plug stuff into it, right? Do something, but you can't let it throw you, okay? Because unfortunately, if you read part A and went, I don't know what to do, and you let that make you panic, well, now you're missing out on other pieces that I would say are much more straightforward, and for most students were ones that were much more doable. I know, having talked to students who I've walked through this with in the past, most people like C and D best. So I'm actually going to skip down. I'm going to do C and D, then B, and then A. Because honestly, even if you didn't do A at all, you could still get a 5. This particular year, even if you didn't do A at all and missed out on a point on part B, you could have still gotten a 5. And we're not talking even 4 and 3 range yet, right? Like you can't let it throw you. The skewed percentages are there for a reason. You might not finish every problem on your AP test, and you have to be okay with that. I'm sorry. I wish I could tell you otherwise, but that's just the reality of taking the AP test, right? Don't let it throw you. Okay, so like I said, I'm going to do C, D, B, A. One more time, we have the graph of the continuous function g, which is the derivative of f, so I'm going to go ahead and write f prime here, is shown above. The function g is a piecewise linear between -5 and 3. I've got a function defined for this quadratic from 3 to 6, and so I'm going to go ahead and put 2x minus 4 squared in there just to remind myself that I know that equation. Okay? Coming down to part C then, it says, between -5 and 6, on what open intervals, so I am going to make sure I do parentheses for my bounds, or inequalities without the equals, right? On what open intervals, if any, is the graph of f both increasing and concave up? Okay, so what does it mean for f to increase? Okay, well that means f prime is positive. What about concave up? F prime is increasing, F double prime is positive. We've got our little table that we wrote down for that, right? Okay, and so that's what I need to see both increasing and concave up. Okay, well what kind of graph do I have here? I've got a graph of F prime. And so what I'm answering is, where is this F prime positive and increasing? Okay, well initially F prime's negative, and then it's 0. But then starting here at x equals 0, my f prime is now positive, and what do you know? It's increasing. And f prime here is positive and increasing from 0 to x equals 1. And so that's going to be my first interval. And then f prime's not increasing anymore. and then f prime is decreasing. But then starting here at x equals 4, from 4 the rest of the way, f prime is positive above the x-axis and increasing. And so from 4 the rest of the way, which for this problem is to 6, okay, that's the second interval. Give a reason. Because f is increasing since g or f prime is positive and concave up since g equals f prime is increasing on 0 to 1 and 4 to 6. Okay, this one was worth 2 points, 1 for the intervals, 1 for your reason. And again, as always, there are other ways you could write that reason and still earn that point. Okay. Part D, find the x-coordinates of each point of inflection on the graph of f. Okay, well, remember we have f prime, so what does f's points of inflection look like on an f prime graph? Okay, well, so f prime is increasing to decreasing or decreasing to increasing. Okay, so looking at our graph of f prime there, where do we see increasing to decreasing or decreasing to increasing? Not only 1 point. X equals 4 is the only place where we see that happen. So we'd have x equals 4 and then give a reason. Because f prime equals g changes from decreasing to increasing. Whoops. Increasing, sorry. Increasing at x equals 4. Okay? 2 points, 1 for your answer, 1 for your reason. Okay, part B is going to be up next. Okay, part B, we have evaluate the integral from 1 to 6 of g of x dx. Okay. So integral from 1 to 6. The first point here is I would say a conceptual point. There are several different ways you could earn the first point that's contained within this part. There are 3 total, by the way. The first point is recognizing that to take the integral from 1 to 6, 1 starts here. Let me actually shade this with a pencil. Okay, 1 starts here. And 6 goes all the way over to here. So like I said, the first point is a conceptual point, which it comes from recognizing that to evaluate this integral requires us to essentially consider 2 different integrals. The first one is what happens from 1 to 3. Remember what an integral is. An integral is a total. It is an accumulation. It's an area. It's a volume. Like that's what an integral represents, is that total amount idea. Okay, and so 1 to 3 here, I can actually calculate that area. It's a square. 2 times 2 is 4. Okay, but then there's a second integral I have to think about, which is from 3 to 6, and unfortunately that isn't an area that I can actually calculate, so I'm actually going to have to do an integral on it, but that's okay. I know what the formula is from 3 to 6. It's 2 times the quantity of x minus 4 squared, and so I'll be able to take the integral. Okay, the first point comes from, they call it splitting at x equals 3, but it's that idea that you need to know that to evaluate this integral, you do have to consider 2 different ones. Okay, and so when you look at their rubric, you'll see that they show that idea with this step. Okay. which again, you don't necessarily have to always write stuff exactly like they do. In fact, sometimes I write it very different than what they do, which is why I said that first point is very much a conceptual idea. And so if you didn't write this, you didn't necessarily miss out on that point. And so if you didn't write this and you're not sure if what you did is okay, please feel free to send me an email. I've actually already gotten a couple from students asking. I'm more than happy to clarify that or to check your work for you if you would like, because I know that's a little bit hard to grade there. Okay, so 1 point for splitting at 3. And then like I said, this one's a square here. 2 times 2 is 4. This guy, we actually are now going to integrate our function, 2 times x minus 4 squared. And your second point is going to come from your antiderivative. Now, how you do your antiderivative is going to depend on how you see this function. I know, having already gotten a couple of emails from students, that some students are looking at this and they're just integrating it as is. Because even though this is chain rule, which would require a UDU theoretically, because our DU would be 1, I can kind of ignore the UDU and just do power rule. Others I've looked at have FOILed this out and distributed the 2 in. So they got x squared minus 8x plus 16 from FOILing, and then multiplied the 2 in, got 2x squared minus 16x plus 32. And then they integrated that with power rule. Both work, but both obviously have a very fundamentally different looking antiderivative. Okay? I'm going to do it here on the video with the foiling idea only because it's already written out on the rubric without foiling, and that way you can see it both ways, right? And then choose whichever one you like better. Okay? So again, if I foiled this, x squared minus 8x plus 16, distributing the 2 would be 2x squared minus 16x plus 32. And then integrating would be 2/3 x cubed minus 8x squared plus 32x. Oops, 3 to 6. Okay, that antiderivative is a point. And then the last point comes from your answer, which, as I've said many times, but this is one of the last times I'll get a chance to do that, is this FRQ 8. Remember that you don't have to simplify anything. So I would plug that 6 in. 4 plus 2/3 times 6 cubed minus 8 times 6 squared plus 32 times 6 minus, and then I'd plug the 3 in. 2/3 times 3 cubed minus 8 times 3 squared plus 32 times 3, and I would not simplify. There's too many elements there where you could multiply wrong or something like that, especially if you're going this FOIL route. If you don't FOIL it out, if you do it more like the rubric shows, a little bit easier to simplify, but this is kind of nightmarish to have to simplify, and so I'd leave it alone. It does simplify to 10 though. Okay? Oh, and that was the final point is for the answer. Okay, part A, as I said at the beginning, was the one that I have found over the last several years students tend to not like as much. It's just a little bit weirder. It's the desired position formula, which is I'm given 1 point. I'm asked for a different one. So my given position is 3. The time corresponding to that position is 1. The one I'm trying to find is -5. And going inside is my f prime or my g, whichever one you want to write. Because remember, f prime of x equals g. Right? So you can put either one in there. Which is upside down, so 3 minus -5 to 1 of g of x dx. And then that's just a bunch of areas from -5 to 1. Starting at -5, -5 to -2 is a square below the x-axis, so negative, base of 3, height of 3, so -9, 3 times 3. Or maybe you want to write 3 times 3, you don't even have to write 9, right? Because you don't have to simplify anything. Okay, and then we have from -2 to -1, a little triangle, again below the x-axis, so again negative, -1/2, base of 1, height of 3, so that'd be 3. Or 3 times 1. And then we've got nothing here. And then the rest of the way to 1, right? We're going from -5 all the way to 1. So we've got one more little triangle. 1/2 base of 1, height of 2, which is just 2. And then again, I would not simplify. If you did, this would be 12 plus 1.5, which is 13.5 minus 1, which is 12.5. Or the rubric calls it 25 over 2, if you wanted to write this as a fraction. But again, you don't have to. Okay, 1 point was for the integral, 1 point was for the answer. Okay? Okay, let me know if you have any questions.